Hi, in this video you will learn how to describe the linear operator that corresponds to the multiplication by a polynomial modulo x to the n plus 1. All right, so imagine here that I want to find the matrix that corresponds to the linear operator that is the multiplication by 2x4 plus 3x2 plus 1 mod x to the 5 plus 1. So first of all, what does this mean? Okay. So what it means is I'm looking for the matrix A such that if I represent, so if I have my polynomial, my input polynomial represented by, let's say, A0 x to the 0 plus A1 x1 plus A2 x2 plus A3 x3 plus A4 x4, okay? So if that's the representative of the class mod x to the 5 plus 1 of my input polynomial, then I'm looking for a matrix such that the result will be given by this matrix vector multiplication, okay? So I want to describe this operation as a linear operation, okay? And so the question here is, how do I find this matrix A? Okay. So, and so here I'm not going to redo what we've seen in class. I'm just going to show exactly how to use what we've seen in my class. Okay. And so in a separate video, I give some more intuition as to how exactly the formula that we're about to use is found. Okay, so here is the situation. You have so you're interested in the multiplication by 2x4 plus 3x2 plus 1. So you can have the multiplication by, first of all, you can do this as breaking it down as multiplication by x4, x3, x2, x1, x0. Okay, and it's used, the way it works is with circular matrices. Okay, so if the multiplication by x to the I mod x to the n plus 1, okay, so it works for any n, here n equals 5, is a matrix of the form like this, right? So a block of identity and a block of minus identity, okay, and zeros elsewhere. All right. And so then if, my polynomial by which, the linear operator is the multiplication by which the linear operator is, then my matrix is going to be the sum of the AI where my polynomial for which I want the multiplication is, A0 x0 plus A1 x1, etc. here. So we have here A0 is 1, A1 is 0, A2 is 3, and A4 is going to be 2, okay? So the way it looks like, once you put together all these matrices, you sum all these matrices, the way it's going to look like is your matrix is going to be of this form, okay? So M is going to have, at its first column is going to have A0, A1, until an minus 1, okay? So here it'd be A4. And then you shift everything down, so you put your A0 here, everything until an minus 2, and then your minus an minus 1 goes back, okay? It goes back up, and then you continue, right? So you pop up the an minus 2, and then you shift everything down, okay? Minus an minus 1, and then your A0, and then all the way down to an minus 3, and so on and so forth, okay? So following that recipe, what is my matrix? Okay, so let's leave the recipe here. So my matrix here, so remember here, A0 is 1, and then A1 is 0. So the first column is 1, 0, 3, 0, 2. And then second is going to be minus 2, 1, 0, 3, 0. So you see how I've shifted everything, and then the 2 came back up and picked up a -1 sign, and then it's 0, -2, 1, 0, 3, then -3, 0, -2, 1, 0, and then 0, -3, 0, -2, 1. Here we go. All right. And that is the matrix for which that represents the linear operator of the multiplication by 2x4 plus 3x2 plus 1 modulo x to the 5 plus 1. So now you know how to perform these, how to turn these modular multiplications into linear operators. And that's really important for the practical implementations of schemes like modulo LWE, where there are there's linear operations mod x to the n plus 1, and you want to turn that into something completely linear. Thank you for watching.